Alright, we're just going to look at all the basic shapes that we learned in class. I think there was like 7 or 8 basic shapes. And now we're going to see what happens if we just put a negative in front of the equations for all the basic shapes. So that's what this means when it says when a equals -1. That's just the leading coefficient. And it even says it right here, when a equals -1, the entire basic shape is flipped around the x-axis. Another word for that is reflection. It reflects over the x-axis. It's upside down. And then the other thing it has, I guess it has here, if a equals a negative number other than -1, the width is also changed, meaning it's going to get skinnier or wider. That's actually going to be on the next sheet or the next video within the worksheet packet here. This we're just going to do reflections. So there's 3 examples right here, and it compares it to its basic shape or its parent function. So we look at the first one. Well, first thing we have to know is what the shape looks like. And you're taking a quiz on the basic shapes. You have to know the equation and relate it to the shape. So if it's x squared, I know it's a parabola. It goes up. And if I just put a negative in here, well, the parabola it flips over the x-axis. Okay, and you can put points in. If you put in 1, well, when you put in 1 here, 1 squared is 1. But then you have this negative. So that's why we get this -1. Okay, the x cubed, this is our S curve right here. It goes up left to right. Now it flips. This part's going to go up. Right, this part actually goes up. So now it looks like this. So it goes down left to right. And again, we can plug points in. Here we have the 1 over x. This is where we get the boomerangs in quadrants 1 and 3, and it flips. This is going to go, that boomerang flips down there, and this boomerang flips up there, and this is what it looks like. And to check it, again, if you put in this 1, well, you get -1 over 1, which equals this -1. So you really have to know the basic shapes, and if there's a negative front, know that it flips. Know the big picture, and if you're not sure, then you can plug some x values to see that it does match up with that big picture. Okay, I'm just going to do a couple here, maybe like the first 2 or 3 on here. First one should be a piece of cake. This is the linear one, -x. I know if it's just y equals x, this is what it looks like. Okay, that's the parent shape. So if it flips over the x-axis, it's just going to look like this. So the red part is our graph. So this is our graph right there. Okay, if I move on to the next one, I have -√x. Well, I know I can compare this. This is the parent function is square root of x, and I should know this is the general shape. Kind of looks like half of a sideways parabola. Well, it's going to flip, so when it flips over the x-axis, this is what it's going to look like. Okay, I'm going to erase this part, and this right here is -square root of x. Okay, next one, I can just compare it to the absolute value function. Well, absolute value function just looks like this. Right, this vertex is at the origin. If I flip it over the x-axis, it's kind of like a parabola. It just goes down. It should just look like this. Notice how for these 3, I really didn't plug points in. You really shouldn't have to. If there's just a negative in front, just flip it over the x-axis.